We're told you have a solid that you know is mostly sodium chloride. You suspect that it might have or it may have some sodium iodide, potassium chloride, or lithium chloride as well. When you analyze a sample, you see that it contains 73% chlorine by mass. Is the sample pure sodium chloride? If not, what else does it likely have in it? So pause this video and see if you can figure that out, and it will likely be useful to have a periodic table handy to do it. All right, so let's get our periodic table of elements. And so I don't have to keep going back to the periodic table of elements. Let's get all of the information that we need from it. So I want to think about the average atomic masses of sodium, chlorine, iodine, potassium, and lithium. And the sodium's average atomic mass is 22.99. Chlorine is 35.45. Iodine is 126.90. Potassium is 39.10. And lithium is 6.94. And so now I can remove my periodic table of elements. So here I will put the various compounds, compound, and here I will put the percent Cl by mass, So first we can think about sodium chloride, and I'll do all of these in a different color just to make things interesting. So sodium chloride, well, the average atomic mass of chlorine is 35.45. And if we divide that by the average atomic mass of the entire compound, the entire molecule here, well, then we're going to have the percent chlorine by mass. So that's going to be 35.45 divided by sodium has an average atomic mass of 22.99. And then the chlorine, of course, has an average atomic mass of 35.45. So we have 35.45 divided by, open parentheses, 22.99 plus 35.45, close the parentheses, and then I get it equal. So it looks like it's a little bit over 60%. And that's actually enough for us to go on, because if this is approximately 61%, we see that that's very different than 73%. So already it's very clear that to the first question, is the sample pure sodium chloride? No, it's not, because it has a different percentage of chlorine by mass than pure sodium chloride would. This would be what pure sodium chloride would look like. So it must have been mixed in with something that has a higher percentage of chlorine by mass. So let's look at the other candidates. So we can look at sodium iodide. So sodium iodide. What's its percent chlorine by mass going to be? Well, this has no chlorine by mass, so this is 0. So if you had sodium iodide mixed in with sodium chloride, that would reduce the percent chlorine by mass. It wouldn't increase it, so we already can rule out this character. Now let's look at the next one. Potassium chloride. I'll write that right over here. Potassium chloride. And so its percent chlorine by mass is going to be the average atomic mass of chlorine, which is 35.45, divided by the average atomic mass of the whole thing. Average atomic mass of potassium is 39.10, and then the average atomic mass of chlorine, of course, is 35.45. And we could try to calculate this, but even when you look at the numbers, you can see that the denominator here, this denominator right over here, is bigger than what we had for sodium chloride. And we have the same numerator. So if the denominator is bigger, that means we're going to get a lower value than 61%. This is less than 61%. And since this has a lower percent chlorine by mass, if it was mixed in, it would average down from 61%. It wouldn't go up to 73%, so we can rule that one out as well. And now let's look at this last candidate, and I'm feeling good about it because something got mixed in. So let's look at lithium chloride. What is its percent chlorine by mass? Well, it's going to be the average atomic mass of the chlorine divided by the average atomic mass of the whole thing. I'll just put the chlorine in here just because I'm already in that mode. And then lithium, see, lithium actually has a fairly small average atomic mass of 6.94. So once again, when we compare to sodium chloride, we have the same numerator. But we clearly have a smaller denominator. This value is smaller than this value, and the other number is the same. So this has a smaller denominator, which means that the whole value is going to be larger. This is going to be greater than 61%. So out of all of the candidates, I'm liking lithium chloride. We can actually figure out this value. Actually, let me get the calculator out. We take 35.45 divided by, open parentheses, 6.94 plus 35.45, close parentheses, is equal to, it's roughly 84% chlorine by mass. So this thing is approximately 84% chlorine by mass. So that does the trick. This, if you had some lithium chloride mixed in with your sodium chloride, it could increase, or it would increase, the percent chlorine by mass above 61%. And actually, based on these values, based on the 61%, the 84%, and the 73%, you could actually figure out what percent is your sample of sodium chloride and lithium chloride, if you assume those are the only two things in it.